Hi everyone and welcome to Festive Tech Calendar 2023. I hope you enjoy and learn through the month of December, and I hope you are doing great. Well, my name is Achraf Benalaya, and today I'm going to present Unlocking the Potential Azure Container Apps in Action. As I said, my name is Achraf and I'm Cloud Solution Architect. Everything always about Microsoft Azure. I do also DevSecOps. I'm actually Microsoft certified trainer and I have a bunch of Azure certification. I love public speaking and writing in my blog, which is achrafbenalaya.com. You can reach me at my email achrafbenalaya@outlook.com or to my YouTube channel, which is Achraf Benalaya. Let's present the agenda for today. So we are going to see how to deploy Frontend and Backend application with Azure Container Apps, how to set up Backend access restriction only to internal apps, how to add domain names to Azure Container Apps, how to manage the environment variables, the secret, and how to integrate Azure Key Vault, how to scale out our Azure Container Apps and add Azure Fileshare as persisting storage, how to simply add authentication to Azure Container Apps, what is single revision, what is multiple revision, how work the app container jobs, how to integrate DevOps, and finally we are going to talk about Terraform. So let's get started. So in this part, what are we going to build is Azure Container App environment with two apps, one for Frontend and one for Backend, that will be both exposable for public internet with Azure Container Registry and Azure Log Analytic Workspace. So later, what are we going to do is to stop exposing the backend to the public users and only expose it to the Frontend application. Both applications that we are going to work with is Hunter X Hunter API. I have built a backend API used Web API.NET project, and the frontend also is MVC project using .NET. I'm trying to expose here my favorite anime, and we will deploy this to Azure in order to see how it will work. So if we run the frontend application, we will read this API and we will try to show this frontend. This is actually the API project, and as you can see here, I have a Docker file definition. We will build this definition and push it to Azure Container Registry in order to have our API later. As you can see here, we use the port 3500. So let's go and let's start creating and building stuff on Azure. First of things, we need to create a resource group. Let's rename our resource group RG Festive Tech, and we are going to put everything that we are going to create inside this resource group. So let's use France Central as my location, and let's create this resource group together. Great, now the resource group have been created. The first thing that we are going to need to create here is the Azure Container Registry in order to have our image or Docker image. So let's search for Container Registry, and here, as you can see, you can create the Azure Container Registry. Let's put it inside the Festive Tech calendar group that we have created, and let's give it a name. Okay, we cannot use dash here. Okay, let's remove this, and we will go with a standard plan. We can even go with the basic plan. We don't need encryption for this scope, and we can deploy it actually. Great. We will wait for this to be deployed, and later we are going to push our images to this container registry. Cool. Our registry have been created. As you can see here, we have the name of our registry. We have a couple of parameters they can use, and all the images we will find them later here inside repositories. We can use this quick start in order to log into our Azure Container Registry from our machine and push the pictures that we are, or the image that we are going to host inside the Azure Container Registry. There is a couple of ways to do this, even with DevOps, and we are going to see this later. But for now, let's do this the old way. Let's connect to our Azure Container Registry and push the images that we have. In order to do that, we need the username and the password in order to log in, since we are using our local computer in order to do this. Okay, I forgot to launch Docker. We need Docker to be running in order to connect to that container registry. So let me start Docker. Actually, there is another way, but for now, let's use this simple way. So that's the username and that's the password. And let's connect and build this image and push it to that container registry. Okay, so I will build this API. As you can see, the build have run successfully. Let's tag this image and push it to the Azure Container Registry. I will use the tag v1 and I will use it later with the Container Apps applications. Cool. Now, if we go back here, you will see that inside the repositories, I will see this image here with the tag that I have created. So this is the first image that we have pushed inside this Azure Container Registry. And right now we can build our backend application. First of all, in order to create an Azure Container App, we need a managed environment for these Azure Container Apps. Without it, we cannot create an Azure Container Apps. So let's create a new app and integrate the Container Apps environment. So here, let me give it a name for the backend application. And since it's API for the anime API that we are going to expose, which is Hunter x Hunter, let me give it a name CP Backend Hunter x Hunter. And here I'm going to create a new Container Apps environment in order to host all our application for this session. So here I will go with workload profiles, and here I will not need to be zone redundant since it's only for demo, but for production it will be necessary. Okay, so everything is smooth right now. Let's create this environment. You can click here, create, and we can actually change the workload profile. We can change the monitoring. We can choose an Azure Log Analytics or any other resource. And we can even integrate virtual network if you want to integrate virtual networks. I will go with Azure Log Analytics for now. And it's actually the basic configuration. And we can actually change the workload profile. We can add or auto-scale the workload profile. I will go with the basic as I said. And right now we are going to create our first container as I said. And we are going to use the image that we have already pushed to Azure Container Registry. So here we select our registry that we have created, the image that we have pushed, and the tag v1 that we have tagged to our image. I will choose the default workload profile that I have chosen, and I will go with the minimum CPU and memory configuration. And here we don't need to change anything. Ingress here is to expose our application, and for that we need to enable this, and we can even choose to limit access to our applications only to internal application inside the environment of app containers, or accepting traffic from anywhere. It means public users. We'll see later the limited container app environment. So our application right now will expose it to public in order to see our API in action. And there is session affinity, which means any user that have been successfully connected to the application can go back later and be reconnected to the same revision or to the same container that have been connected to. So let's create this, and we have set up the port 3500, and we will wait for the deployment for our backend application. It will take a couple of minutes. In order to deploy this log analytic workspace, Azure Container Registry already have been deployed, and right now it will be deployed the Azure Apps Container environment, and after that it will deploy the Azure application, Azure Container Apps, sorry, that will host the backend or our API. Okay. So the container app environment have been created, and later we will see the container app backend will be created too. We will refresh. Okay. First time it will take a couple of minutes, but later creating the Azure Container Apps is really so fast. And like that, everything have been created. Let's go up and check our Azure Container App. So here we are inside our source group. As you can see, we have the container registry, we have the container app, we have the container app environment, and the log analytic workspace. Here inside the environment, we can do a lot of things. We can add certificates, we can connect to Azure Fileshare, we can add custom DNS, we can create the apps from inside apps, we can see the logs of all our apps, and we can log stream everything inside the system, and we can change logging options, and we can here have a couple of CMDs that will help us to connect to any app that we have inside our environment. So here, let's go and check this container app that we have created. As you can see here, we have the container configuration and the properties, and you can see we have one revision that is running, and here we can add authentication, we can add secrets. For example, here we have the secret, the username and password for Azure Container Registry because we have connected to it. We can right now actually go and see if the application is working. Let's go and check our endpoint, API characters, and check if our API is working. Great, amazing. So this is the API that we have created, a simple API that will give us the name, the image, and the superpower of our character. And actually now this URL is public, and we are going to use it inside our frontend. Let's copy this and let's use it inside our frontend application on local to see if it is working fine. So I have replaced the URL with the URL of the backend. As you can see here, we have our application on local computer consuming the API that is hosted inside Azure Container Apps. Okay, cool. But right now we want to keep that backend private. It means it will be exposed only to the application inside the Azure Container Apps environment. So for that, we are going to see how to do it. But first, let me push this solution to the Azure Container Registry, as we use it to do. So we will build the project, we will tag it, and later we are going to push it to Azure Container Registry. Cool. Like that, the project is being pushed, and we will have inside the repositories a new picture of a new image of another application. So here I'm going to create a new container app, Okay. And I will choose the same container app environment that you have created already. We will choose right now the container registry that exists and the new image that is pushed, which is Hunter x Hunter frontend. I will keep the same configuration. I will only change the ingress port, which I will use the 80. I have configured here inside the Docker file, or I have exposed the port number 80. And for that, I will use it in order to expose the front-end application. Cool. Check this here. And I will ignore client certificate mode for now. Everything is fine. And right now we are deploying this front-end application. So the both container apps will be running in the same environment right now. And we will see the result shortly. Having these both applications in the same environment is so important when we are going to test, because the goals here is to put the backend in private mode. So here, let's go and check the front end, and it's right now exposed and it's hosted inside Azure Container Apps, as you can see the URI. And here we have every character from Gon, Kilwa, Yuri, Korapika, and everyone of the team, even the spiders team or the phantom team. Great. So everything is working fine and the API is here, but it's always exposed, and this is bad for any project. We do not want anyone to see our backend. It's only up to us to consume that backend, and no one should be seeing it. So for that, let's go to our backend, and inside the ingress configuration, we have seen it before, and right now we are going to apply it. We will limit to only container app environment, which means, as you can see, the URL will be changed. We will have internal inside the URL. It means only the application inside the container app environment will read this API. So if I run this, as you can see, it's 403. I cannot access it anymore. And if you can see here, we have a new URI, and it will contain the internal word, and it cannot be read from external or to public users. So what I will need is, as you can see, our application, the front-end application stopped working because we don't have API exposed to it. And we need to update the URI inside our application. For now, we will do it from here, but if you want to do it smoothly, you can do it from app environments, and we are going to talk about environment apps and secrets later. So I will update the URL from here, and I will push a new image to Azure Container Registry, and I will update the Azure Container Apps in order to read this version of the application that contains the URL of the backend, the internal backend that we have created. Cool. Now we have our image pushed to Azure Container Registry. And right now, let's go to the front end and update our container in order to deploy a new one with a new the new image or tag that we have pushed. Let's save this, and by that, a new revision will be created. Okay, so it will be updated and it's already deployed. If you can go to revision, you can see it's been activated, and the old one or the old version of the application, it will be deactivated. Let's go and check if our front end is working. As you can see, the front end is working very fine, and we can see our application. So this was the goal from this presentation. Our API is hidden and our front end is presenting and reading data from that API. And this is the example how to do it in Azure Container Apps. We will see you right now in the next part when we are going to talk about other stuff and we will see it together. So it's true right now, we have applied all this and we have our application exposed to the public internet. But what it will be good is that we'll add a domain name to our application. And like that, we will well present our application instead of sharing the existing URI that we have seen before. So what are we going to see right now is we are going to see, instead of using this URI, how to add a domain name to our application. For that, we are going to need to have an account in GoDaddy or any website that sells domain names. And later, inside of using this application URI on sharing with public users, we are going to share with them a custom domain. For that, we need to go here, add custom domain inside our application, and we are going to use that IP address of the application in the custom domain verification. So I will use managed certificate, and I will go here inside GoDaddy in order to manage the DNS of my domain name, and I will add actually two records, type A, and I will replace this one because I have used this with another application. I will save this. Great, and I will add this text record, and let's continue and verify. I need to verify the action, so I will receive a verification code. Okay, I have saved this, and right now I will replace this. For you, if you have not done this before, you need to create a new record, type text, and add that name ASUID and insert that value. Great. Now let's validate that. And the validation have passed. That means our Azure Container App and our DNAs are connected, and we have confirmed that domain name belongs to us. Right now we need to add binding for securing our application. I have already done this, but I will show you where you can do it. You can choose CNAME for applying this, or you can choose a record. As I said, I have already done this, and what actually you need to do is to generate an SSL certificate in order to secure the access for your application. So for that, I have used 0SSL in order to generate a certificate and install it inside my domain. And as you can see right now, I'm going to validate, and the statue is secured, which means I have a valid SSL certificate related to my domain name. Now, let's check up the domain name that I have configured for my application. Let's go to this, paste, and as you can see, we have our domain connected to our application, and this can be exposed better than the other URL that is automatically generated by Azure. Let's paste here in private navigation and test it. I help you to do. And let's go, and this is our website running live from inside the Azure Container Apps. So this part was about the domain name. You need a domain name, valid domain name, and you need a certificate. You can use GoDaddy in order to have that. So this part was about the domain name. See you in the next part. So if we want to go forward right now, we have added domain name, we have a front-end application, back-end application, SER. But what if we know we need to add environment secrets, environment variables, or add secrets to Azure Key Vault? And this is what are we going to do right now. We are going to see how to Azure or integrate Azure Key Vault, and how also to read environment secrets or environment variables. So let's go to see our application here. I have modified a little bit the application in order to read environment variables and show them inside the front-end application, since we are not going to use the backend to show environment variables, but we will use the front-end application. For that, let's go to our front-end, and it's going to be like that. Let me just go and modify a bit in order to show you what are we going to see inside our application. Let me run the front-end application again. So we have Hunter x Hunter application front-end, and inside it, I'm going to show the secrets. As you can see here, by default, we have the secret of Azure Container Registry when we have connected our application to Azure Container Registry. Right now, I'm going to add a new secret. As you can see, you can refer a container app secret or a key vault secret. And also inside the containers, we can edit our containers and add environment variables for the containers. Now, to be clear, this environment variable cannot be shared between the containers, but the secrets can be shared between the containers. So right now, the first test, we are going to work with environment variables. So let me add an environment variable here, container secret. Let's enter it manually, and let's enter a value. Let's name it environment variable demo. And let's deploy this third tag that I have pushed in order to read this environment variable. So let's wait for the result in order to read this environment variable. So let's go to our application. Let's run it. And below the picture, in the middle of the screen, we should see the environment variable that we have added. Let me refresh the page. All right, great. So on the right, as you can see, secrets, we have the environment variable demo text that we have inserted inside the environment variable. So this is, we are reading an environment variable from inside the container dedicated to this container only. This is great. Now, what if we want to share secrets between containers? For that, as you can see here, we have entered this manual entry, but right now we can add secrets here inside the secrets add. We can add a key for the secret. For example, let me refer the same name, and I'm going to write another secret here. Let me just copy and paste. Let me copy this so I can do it quickly. Let me, we are not going to reference key vault, we'll do this later. And here I'm going to name the value container secrets from here. So let's update the secret. And now what actually we need to do is to reference this secret inside the environment variable. So as you can see here, we have our secret, and inside the environment variable, what we need to do right now, actually, I'm going to modify this container like that. And this is, I will change it to reference that secret that we have created, and we can right now show the value that we have created. Let's update our container. And right now, what we need to see is the variable that we have saved inside the secrets. Let me refresh the page, waiting for the deployment. It will take a few seconds in order to see the new version deployed. As you can see, the secret have been changed into the secret that we have added inside the secrets. That's amazing, and this can be shared between all containers. And now, what are we going to see? We need to reference key vault in order to secure our variables. So what we need to do is to create a key vault, reference it right here, and reference the secrets that we want inside our application. So if you go here to secret inside the backend, for example, okay, I can create secrets also. As you can see, this is secret for the Azure Container Apps. Cool. Let's go back to secrets here. Now we have two secrets, and now let's add one that reference key vault in order to read secrets from the key vault. For that, we are going to create a key vault by searching for key vault, create. Let's put it in the same resource group that we have created for our festive tech calendar. I want again to thank the team for giving me this opportunity to share with you my knowledge about Azure Container Apps. Okay, I do not want to retain the deleted vault because I will put 7. Okay, so we can use the key vault in order to save our secrets, and I will use the vault access policy instead of role-based access management in order to save the secrets that we are going to use in this demo. Next, I will put for now enable public access, but if you have a real project, you will use virtual network and you will only use private endpoints or virtual network in order to read secrets from the key vault. Great. So the Azure key vault is right now being deployed. It will take a couple of seconds in order to be ready for us. And here we can actually create the secrets. I'm going to use this variable key vault from secret from key vault in order to integrate it inside our application. And the secrets, I will use these secrets. So I will create it right here, the URL of festive tech calendar. So I will copy this and it will be our secret. So let me paste this and set expiration date. Okay, and let's save or create this secret. Okay, our secret already created, and now we need to give actually access to our container apps in order to read from this key vault. For that, we need to enable identity inside our Azure Container Apps. Actually, there is another way with user assigned identity, but for the demo right now, we will use only system assigned identity. So we need, as I said, to enable system assigned identity. So an identity will be created in Entra ID and can be referenced inside the access policy for the Azure Key Vault. And like that, we will permit our Azure Container Apps and give it access to list, set, and read the secrets from this key vault. For that, we need to go here. We need to create. Let's get list and set for secret permission. And here we need to give that identity and create. Like that. Now our Azure Container Apps have the access to read secret from that key vault. Let's copy the secret identifier. And right now, let's go to our application, secret, and add. And right here, we are going to give it a name and reference it. So this is the key vault reference. We put the reference for the secret, and in managed identity, we set it as system assigned. And let's copy this. I'm going to use it as key. Add. Great. This is amazing. So it's successfully updated. Now let's go to the container and modify the environment variable. Okay, and let's reference this secret that we have created from the key vault. Let's add a new one. Let's give it a name. Let's set reference as secret, and here we have the secret from the key vault, and let's save. Now we should see a new secret here below secret from key vault. Let's save, create, and wait for a new revision to be created. Here we are using single revision mode. If we have multiple revision mode, we can deploy another app. We won't need to wait for this app to be deployed. We will talk about this later. As you can see here, we have the right secret from the Azure Key Vault, and it's working fine. So this is what the demo about the Azure Key Vault and environment variables and secrets, and I hope you have found this helpful. See you now in another thing. Let's go. One of the important things in any application is to learn how to scale it out. Right now we are going to move to scaling out Azure Container Apps, and actually there is 3 ways, as you can see: HTTP, TCP, or custom ways in order to scaling out our application or having more instances. So we will focus right now on HTTP scaling out, and later we are going to see the custom way with Azure Service Bus. And this is actually very important in order to maintain our application live. So let's see how to use the HTTP scaling out rules. As you can see here, we have our replica. I have 2 replica actually right here. And here we have the scale menu. As you can see here, I have minimum 2 replica and maximum 2 replica. If I edit this here, we have the scale menu. And here we can change the maximum and minimum replica, number of replica that you can have in our in our container apps. We can have maximum and minimum of, we can change them up to 300 replica for each one. So let's create a rule for HTTP and let's test it. So I will put, let me change the maximum. I will put 22 and minimum 2 replica, and let me set a rule. So this rule will say festive tech rule or HTTP rule. So it's HTTP scaling, and it will be scaling up if I have 10, or let me choose 15 concurrent requests. So if I have 15 concurrent requests, I will be scaled up to 22 replica. Okay, let's create a new revision and see what happens. And for the demo purposes, I have already created an Azure load testing test in order to do some load tests to our application. So here, what I'm going to do is to run a test with 30 users connecting simultaneously to our application, and to see actually what will happen to our application, if it will scale up or not. So as you can see here, we have total 2 replica running, and what we need to do, or what should happen, is actually if we run the test with 30 users, as we have set a rule with 15 users, we need our replica to be to maximum, which is 22 replica. So what I'm going to do is to run the test and see what will happen. So this is the website that we will be running test on it. It's the front end, and right now we have only 2. It's up and running, and now we need to run the test. It will take a couple of minutes, not a long, but it will run after a few seconds maybe. Let's send the URL, 30 virtual users, and the test, I will put it 1 minute and preamp 1 minute. Let's start the test and wait for the result. Okay. Cool. Right now our test is running. It's still not running. Actually, it's provisioning. Okay. And when it will be, when we will start seeing executed, actually, then the test will start sending it requests. Let's refresh here. And once the test start executing, we will see the number of replica will be incrementing one by one. So it's executing, sorry, as you can see. We will have later here some info, but let's refresh. As you can see, this is great. The number of replica is increasing one by one. Let's refresh. We have 3 active, the other are activating. Let's refresh one more time. As you can see, we have almost the 22 replica running and serving our website. If you go to revision, you will see here we have total of 22 replica. This is the maximum that we have set running. It's a matter of refresh screen and you will see everything is working. So this is our configuration that we have set, and this is how the replica are being creating through the scaling rule that we have created in our demo. So this replica, the 22 replica, are up and running, and we can see in log stream the logs of each one of these replicas. You can see here. We can go through the logs of the console inside each replica, and even the system logs for the replica. Cool. So like that, we can say that our rule have respected the rule that we have created. Unfortunately, from the menu, we cannot set a rule to scale down the replica, but eventually in about 10 minutes or 8 minutes, the number of replica will be scaled down to the minimum number, which is here in our case 2 replica. As you can see, the test is still executing, and after each finish, the number it will be start decreasing until having to minimum number of replica. Okay, so I will wait in order to show you how this happens. As you can see here, we have some data about the CPU usage, the memory, and the network. I will wait just for the test to end. Let me refresh. Okay, the tests right now have been done. As you can see here, we have some result about the server side metrics for our Azure Container Apps, the nanocores, and we can see also the results about the engine health. Okay, the number, the CPU percentage, the memory percentage, etc. Now, in a few minutes, actually between 7 maybe and 10 minutes, these replicas, if there is no calls like the rules that we have set, the number will start decreasing until having the minimum number of replica that we have defined before. So let's refresh and wait a few minutes in order to see how this replica will be. As you can see here, not running, it started to be stopped. As you can see here, if we continue refreshing, we will see until we will have only 2, which is the minimum that we have set. 3 and 2. Great. Now, in our revision, we have only 2 replica, since we have no more calls that is more than our rule that we have created. So this is the part about the scaling with HTTP. Later we are going to see with Azure Service Bus. I hope you enjoyed this demo. Let's go to the next part. So after seeing how we can work with the scaling out with HTTP rules, visit rules, right now we need to focus on adding custom rules based on Azure Service Bus. So for that, we are going to create a new resource, which is Service Bus, that we will use in our test. For that, let's look inside the search command for Service Bus, and let's create a new instance or namespace. Let's put it inside the same resource group that we have created, and let's give it a name for the namespace that we'll use for our project. We are going to use topics in order to send them to our application, and we need to choose the standard tier because in the basic tier there is no topics. So for the networking, I will put right now public, and let's create this service bus resource. Okay, here we will be focusing on KEDA. So we will see how to scale out basic on KEDA and how we'll configure this inside Azure Container Apps. By default, KEDA is existing inside the app container environments. If we go back to the app environment, we can see here that we have KEDA with version 2.10.0, and also we have Dapper, another component that you can use too. Okay, now we have our service bus almost created. So I have these errors because I have logged into a service bus and the service is still creating. And actually, what are we going to create here? We are going to create a new topic with a namespace. So KEDA is familiar for the people who are working with Kubernetes. It's an open source project that can enhance Kubernetes scalability by dynamically adjusting the number of pods based on event-driven workload. And in our example, it's based on the topics that we are going to receive from the service bus. So this is the event-driven context. So let's go to our service bus namespace. Okay, great. So this is the menu of service bus. We need to create a topic from here. Let's give it a name. Let's give it festive tech topic maybe. Okay, let me type this. Festive tech topic. And I will just keep everything as it is for now. Let's create. All right, the topic have been created. Let's go to the topic, and a topic actually need a subscription. But before that, I'm going to create a shared access policy in order to allow our application to access to our service bus. So let me write festive tech SaaS and give it manage access in order to listen and send. Okay, great. We are going to use this configuration later. And right now, let's go to topic, our topic, and create a subscription. Let's give it a name, festive tech subscription. Okay, and I think I will keep this to max delivery count 20, and I will keep everything else as it is. Great. So we almost have everything, and this is actually the service bus explorer that we are going to use in order to send our topics. So from here, send message. We will configure later in order to send our topics from here. Okay, right now, let's go to our container apps. I will use the Frontend application in order to do the configuration. So first thing, I need to add that connection string with the service bus that we have configured. Let's go to the shared access policy and let me copy the primary connection string for our service bus because we are going to use it in order to connect. So inside our secrets, right now we have, and we have already seen secret, we are going to add these connection string. Great. Right now, what we need to do, instead of creating HTTP rule, we are going to create a custom rule. So inside scaling, here I will just adjust it to 15 and create a custom rule. It's the same menu when we have created the HTTP rule. So let me name it service bus demo and choose custom. And here we need to insert that service reference, service connection, reference. And we are going to copy the parameters from the GitHub website here, because we are going to need them in order to configure our event-driven scaling out process. So we need the connection, first thing, to add inside the variables here that we are going to define. So let me paste inside the metadata connection, and we will reference to the secret that we have just added. And we are going to use a couple of these parameters in order to configure our KIDA. So let me add the connection from env, and I will reference the secret reference here. Let me write this down, svc bus connection string. Okay, and we are going to need a couple of others. Let me copy this message count. This is by default 5, and I'm going to configure message count right now for 10. So every 1 plus will have scaling by 1 more. Let me add also this parameter, which is the namespace that we have created or defined inside the service bus. So we need to go check this inside topic, the namespace that we have. So this is it. Let me copy this here. Okay. Also, we are going to use, let me take the subscription name too. So we have already created the subscription. Inside subscription, yes, here. Let me copy this, which is festive tech sub. Okay. Great. And right now we need only the topic name. I think this is the last parameter to add. Okay. Let me check. And I think this is it, and we need to give a rule name and type. We can the type is from the GitHub website too, which is connection. So here which is Azure service bus type. So this is actually the trigger. Okay, so we have created the rule. Let's create it. We have added the rule. Now we need to create it, and in order to test it, we need to go to the service bus, and we are going to try to send some topics in order to see if our application will scale out or not. So this is the minimum that we have defined. Okay, we have the rule already enabled right now. We have the minimum replica numbers respected. And let's go to our service bus explorer in order to test sending our topics. Let me change this to application JSON, and I will send this data just only for tests. And I will send, let me say 300 message and 2 milliseconds between each message. So let's send and go to our container apps and to see it in action. Refresh. As you can see, we have our number of replica is increasing more and more, one by one. And since I have sent 300 topics, we should see 15 replica working all at the same time. All right, we have right now, as you can see, the 15 replica working. As you can see here, total replica is 15, and we have our app running, and we have applied an event-driven custom role that is listening to the message from our service bus and increasing the number of replica based on the count of these topics that we have received. This is actually good, especially if we have a lot of topics that we are going to receive. Now, if we want to export the definition, the YAML definition of this configuration, we can use this command that is Azure Container App show our application. Let me go just and open the YAML file configuration. And if we scroll down, we will find the minimum replica number and the maximum replica number and the criteria and all the configuration that we have set through our demo. So this was the event-driven test, and like that we have applied two scaling out ways, which is the HTTP and custom. So right now we are going to move to another subject. Let's go. Now in this part, we are going to see something else, which is persistent storage. For that, we are going to use two new applications with Azure storage account using the Azure Fileshare. We can use container file system and temporary storage to stock temporary files, but for this demo we are going to use Azure Fileshare in order to save pictures, PDF files, and whenever we want to save. For that, the first application, I will call it the writer application. We will be responsible for uploading data to our Azure Fileshare or to our persistent storage, and we are going to have a second application that will be responsible for reading these files or data that we are going to save inside Azure Fileshare. If we resume, we will have two applications that we will access the same Azure Fileshare in order to save and read files. So here, as you can see, we have our first application that is reading the files that I have saved. It will be like that. I'm running the solution inside my local host. And as we have done before, we will deploy both application, the file writer and the file reader application, to our Azure Container Registry. All right, so let's start by building our solution. Here we are building the first solution, which is the reader. I will build it, I will tag it as usual, and I will push the image to our Azure Container Registry. Good, we are good right now, and now we need to deploy our other application. We are pushing right now this solution, and now inside the writer application, I will build it, tag it, and push it. Both solutions, you will find them in the same repo that will contain also the other solution that we have used with the Backend API for Hunter x Hunter Anim, and also the Frontend. Great, now we have tagged it, and the last part is pushing this image. Great. So this is another storage account that I have used for another demo, but I'm going to create a new one step by step for this demo. So, and this is another application. Let me just go back and to the actual resource group. So here inside Azure Fileshare, Azure File configuration in our environment, we need to configure Azure Fileshare. For that, we need to look for storage account, and we are going to create a new one right here. So I will choose the same resource group that contain our Azure Container Apps. I will give it a name, ST Festive Tech Calendar. I will just remove the dash like that, and I will remove, I think, all right, let me remove this. My keyboard stuck sometimes, and let's remove this dash. We can't actually. I will keep it in front central, and I will go to advanced. I will keep everything here as it is. Network, I will keep it public for right now, and I don't need soft delete for the demo. I don't need encryption. I will keep it as it is configured, and I will create my storage account. It will take a couple of seconds in order to see our storage account. Okay, great. That was so fast. Here we have Fileshare that you can use it for persisting storage. Let's create a new one. Let's give it a name, and let's just create it. Cool. I'm configuring Azure Fileshare with backup right now, and here we are going to configure the Azure file in order to be connected to. So I will give it a name here, Festive Fileshare. I will just go here and copy the storage account name. We need it. We need also the storage account key. We will find it inside the storage account. Let's copy this key. Okay. And the file share, I will choose write and read role because we are going to read and write inside this file share, and I will copy the name of the file share that we have created. Amazing. Add and save. We need to, okay, everything seems fine, and I didn't save this. Let me refresh. It seems fine. Let me save it. Okay, now we have our Azure app environment, container app environment, connected to that Azure file share, and it's have like that an Azure file storage related to our Azure app environment. And let's right now create a new container app. Let's start by the application that will upload the files. I will choose the application responsible for uploading the files, and I will choose the appropriate image, which is storage writer, and the tag that I have used. Okay, I will go with this, the minimum. I don't need something else special for this application. Okay, and right now I don't need environment variable right now. Binding, I don't have any binding right now. Ingress, I will expose this application in order for users to upload their files. For that, I will go to the Docker file. I will choose the port number that I have exposed here, 80, and ignore and review create, and create. I think I have forgot something, which is putting this application accessible from the internet, because I think I kept it limited to Azure Container Apps environment. Let's check this together. Let's wait a couple of seconds in order to see our Azure app environment. Okay, let's check the application. And as I thought, I forgot to change the ingress controller and put it public traffic access. So I will save, and right now we will access the application. Okay, let's check our application and try it and see if it works. So let's upload our data. Let's see if it will work. So let me close maybe this and go to the portal. Let's have a page when we can access the Azure Fileshare in order to see if we can see files being uploaded right there. So here we have the Azure Fileshare. Let's go and browse. We have nothing right now. We're supposed to see folders, and okay, let me try to upload one of these pictures that I have. Okay, nothing yet. I think I forgot to create the directories. Maybe I forgot to do this in the Azure Fileshare configuration, or I may need to restart the application in order to create those directories. Okay, let me check right here. I'm going to check. I forgot actually to add the mount path for this application, and that's why I couldn't see the files that I have tried to upload it, because I have defined here the /upload path in order to upload the files, and I forgot to define that in the environment variables. So we are going to see the application deploying again, a new revision. Let's try again. I think it's still being deployed. Let's wait a couple of seconds and try again. Let's take this one then. Okay, right now, as you can see, we have both our files, but both our pictures that you have uploaded already exist in the image folder, and we have the PDF folder too. Let's try to upload another picture and see. Upload. Let's go to the picture folder, refresh. As you can see here, we have the 3 pictures that we have uploaded. Let's try to upload the PDF file and see. Upload. Let's go back here. Let's go to our PDF file directory, and as you can see here, we have the PDF file that we have uploaded. Now it's time to see the reader application, if it is possible for it to read from that Azure Fileshare. For that, we are going to deploy a new application that will be responsible for reading data or files from that Azure Fileshare. So we have deployed already this image to the Azure Container Registry. Right now, let's use this image, which is the reader and the tag. Only one tag we have. This is the version number 1. Let's try this one. And for the ingress, we will keep this application accepting traffic from anywhere, which is mean public application. The port number that I have configured for the Docker file, which is port 80. Let's use this one. Okay, and right now we can create this application. Good. Deployment in progress. Amazing. We will see right now the application being deployed. Let's refresh. And like that, we have our another Azure App Container or a container app being created. Now we need to configure, as we have done in the reader file uploader application. We need to add the environment configuration, and for that we need to add the file share here and the mount path, the same mount path that you have configured before. So this is it. App upload, save. A new revision will be deployed, and what we need to see right now, if our application will work fine, is that we will see the files that we have inside the file share, which means the PDF file and the pictures. Let's wait for the application to be deployed. This is an old version without the file share. As you can see here, if I refresh, we have our file application that read the files, the pictures that we have. And if I upload another one right now, let me upload this. Okay. Let me refresh this. And as you can see, one more file that we have, which is the PNG file application picture, sorry. If we right now delete this PDF file and refresh our application, we should see that picture, that file gone. As you can see, we don't have any more PDF files. And if we try to upload it again, we need to see it one more time. Good. And this is our PDF file right here. So this was the demo about using persisting file storage. We're using Azure storage account and Azure file share, and you will find the solutions that I have provided right here in the demo in the same GitHub repository that I will share in later at the end of this video. Let's go right now to secure our application. Now in this part, what we want to do is to secure the access to our reader file application through Entra ID, which is used to be Azure Active Directory. For that, we do not want anyone to access this application. Why? Think of it like if you have a website where you can upload your resume, and only some people will, we need only some people to access this. For that, we need to configure authentication through an identity provider, which is Microsoft. And here we are going to create a new app registration. Let's name it CP Fileshare app. And we are going to give access to any Microsoft Entra directory and even a personal Microsoft account. And we will force access to this application, which means no one can access this application only if it is assigned. We can add permission. For example, here I will say I need to read your email and user ID in order, or user profile, in order that you can access this application or this website. So let's wait this to be configured. Okay, great. So this is configured right now. If I go to the home page and refresh, let's wait for it to be applied. And let's go to our app registration and check for the new app that have been created. Let's search inside, not here, inside all applications. As you can see here, when I refreshed the page, automatically it asked me if I authorize this app registration to access my profile and my email in order to access the website. Amazing. So this is, I will copy the application ID and look for it here inside the app registration, inside all application. As you can see, this is the app registration that I have created. And here we can access the application. Let's copy this and go to private navigation and see what's going on if we try to log into the website. As you can see, we are being redirected to access through Microsoft login page. Here we can see all the setup that was automatically configured through the application. As you can see here, we have the redirect URL, we have the API permission that I have configured at the beginning. We can define roles and administration right here. We can define owners, branding. We can have here an integration assistant. We can have a couple of other applications that we can set up. Here we can set up the branding and properties. And we have the manifest file right here. Cool. What are we going to do right now is we are going to look for the enterprise application. As you can see here, we have application ID URI. We are going to configure the enterprise application in order to restrict access only to the users assigned to this application. For that, we are going to add a couple of users here in order to give them access to the application, because if we don't configure this, anyone with a Microsoft account will access the application. We need to set assignment required to yes right here. Okay, and inside users and group, we need to add users actually that we will allow them to access the application. So we'll check one of the users that I have. Let me look for Batman. Yes, Batman still have an account at our Entra ID. So let's go and try to access with Batman with the username and password. As you can see here, Batman is not authorized to access our website because I didn't assign Batman to that app registration. Now what are we going to do is go back to that application, and here inside the users and groups, I will just go here. Let me check this before. Okay, it was assignment required and user groups, and I have added Batman as a member. We can select members or group members. It's better to work with groups, but for the demo we will use members, and I will try to log in again to the website with the same user Batman that I have tried before. Okay, let's try to access. Let's type the password. Let's have this, and right now I will have this prompt to authorize my application to read my profile and my email, and I will accept this and I will be redirected to the website. So this is what the easy and fast way in order to give authentication only to the users that we have configured inside our enterprise application. And this was a 5 minutes setup that you can do it and secure your application without any effort for coding. This part was about authentication. Now we are going to move to another part. We will see another stuff related to Azure Container Apps. I hope you enjoyed this part, and I hope you applied. Let's go right now and talk about Container App Revision. Revision in Container Apps can be used in order to versioning and revision, which means deploying multiple version or revision of your containerized application. For example, if you have scenario about a new feature or bug fixes or improvement for your application, or for example, rolling update for users without having downtime. This is actually great. Also for A/B testing or canary testing or any kind of testing, and also for configuring changes. For example, if you have a new app environments, and also can be used for health monitoring if you want to monitor different application. What are we going to build is same container app with two revision, one with 60% of traffic and one for 40% of traffic. But first of all, we need to do something inside the container app that we have. Here, as you can see, we have a revision. Let's go and see our website. Here we need, as you can see here, we have the traffic 100%. And here we have the replication for the demo that we have used before. Here we need to change the revision mode. And let's see our website. This is our Hunter x Hunter frontend. And here instead we are going to change the revision from single mode to multi-revision mode. Here we can have multiple revision at the same time. So let's wait for this to be updated quickly. And as you can see here, we can click on the traffic and change it. For that, I'm going to create a new container app in order to test it. So as you can see here, I can change the number here in traffic. For that, I'm going to remove this container and create a new revision with another container. Let's use a basic Nginx image from Docker Hub, which is Nginx latest version. Add and let's create this revision. So here we are going to see two revisions at the same time running. As you can see, the second one is being activated. Great, it's being activated. And if I go here, we can have Hunter Center website. And if we go to the other revision, we will see the Nginx default web page. Great. So we have two revisions in the same app, Container Apps. And if I go to the main URI of the Container Apps, we will see the Hunter website because we have set by default 100% of the traffic to go to that revision. Now I'm going to split 40-60. Okay. And let's go to the main URI of the container app and refresh the page, and we'll see the traffic. So 1, 2, 3, 4, and here we have the welcome to Nginx web page 2 times, and we will have the welcome to Nginx web page. So it's 40% for the Nginx website and 60% for the Hunter website. We can set 100% to the Nginx, and we'll never see again the Hunter website, which is something I don't like it. I want to see the Hunter always. Okay, as you can see here, let me see. So we have here as configured 100% welcome to Nginx website because we have changed the traffic to that application. Cool. So here we have seen the multiple revision, and you can use it for testing, for monitoring, for making changes or updating changes, and seeing what's going on inside the revision, even without changing the traffic. And later we can change the traffic in order to publish the application in the prod environment or in UAT environment. This was the demo about revision. See you another demo later. Another amazing thing that we can do in Azure Container Apps is jobs. Jobs, we can configure them manually or automatically, and this is actually amazing for doing a lot of things. So here we can trigger manually and schedule, or for event-driven jobs also we can do an event-driven configuration. Today what are we going to do is to create a simple Azure app job based on this console application that will read data from a SQL database table and move it to another table. And we will use the SQL database. For that, I'm going to create a SQL database for this demo. Let me create a new instance of SQL database inside the same resource group that we have configured. Let's go here to our festive calendar. Let's give database a name. Let's create a new server for this demo. Let's give it like that. I will use the same location that I have used it, and I will use SQL authentication only for this demo. Server name admin, we need to set up this and the password for that admin. Okay, let me just paste it. Okay, amazing. And let's do okay. Great. And we don't want elastic pool for this, and we don't need it to be geo redundant. And we will put this right now public accessible, and I will allow Azure services to access to this server. And let's For security, I will keep it basic. Okay, here we don't need backup. We are in a demo for something else, and let's create this server with the database. Okay, it will take a couple of seconds as usual in order to see this being created. And here we have the Docker file of this solution, and here we are going to set up the default connection string. I will remove this in order to replace it with the configuration from the new SQL database instance that I have created. Let's wait a bit. Okay, the SQL server have been created and the SQL database not yet. Let me remove this. Okay, let me remove it from here. Later you can use the environment variable in order to set up the this configuration. Okay, now we wait a few seconds more in order to see this working. Okay, right now we have our DB ready, and I'm going to use the ADO.NET SQL Authentication in order to paste it and use it with our application. Okay, let's paste it right here, and we need to set up the right username and the password in order to be connected to our instance. This is not the best practice, but just for the demo, we are going to see it how to work. Okay, as usual, we will build, we will tag, and we will push our solution to our Azure Container Registry. Okay, let's push it. Okay, and here we are going to connect to our SQL server from the portal. This is actually great. We don't need to use SQL DB connector like Microsoft SQL Server Management Studio, and you can do it actually from here from the portal. As you can see here, I'm going to create two tables, one for the received data and one for the archived data, and I will try to answer right now a couple of data inside the received data database. In the table here, as you can see, in our table we have a couple of data, and inside the archived data we don't have anything. Now the goal from this job is to move these data from the received data to the archived data. Normally I will do this as scheduled job via time, but for the demo purpose I will use it manually. This means I will actually run it manually by clicking on start job. So let's create a container job app. You can schedule this, or it can be based on event driven, for example a queue message, and we will choose right now the image that we have pushed already, which is the DB job image, and let's create our container app job. So let's connect again to our database in order to see our two tables before to run the job. Okay, so our container apps job have been created, as you can see, and we can click on run now. And here we can see our containers, here we can see the logs, you can see here the execution history, because I have clicked run, so it will be running, and you can see the logs from inside the log analytic workspace right here. It will take a couple of minutes in order for the, as you can see here, we have the logs for our images that have been pulled and started running. And here will take a couple of minutes in order to see the actual logs of the job. Let's refresh. Our job has succeeded. So let's go and check our tables. Here I will try to see the logs. It's not still not, as you can see here in our database. Let's go and see in our archived data, we have the data that you use it to have inside the received data. Now our job have succeeded to remove the data from one table to another table. We can schedule this per time or by event driven, or we can use it also manually in order to clean tables, for example. This was about the jobs in Azure Container, and we can use them in different situations. Now let's go and see something else. So what about DevOps? Can we auto-update this revision? Yes. So here I have a pipeline that we have prepared for this in order to automatically push the image and deploy it to our container apps. So this is so simple. We only need to push the image that we have created and inside our Azure Container Registry. And as you can see here, I have a couple of variables that I have configured. For example, the repository name. For example, here I'm trying to update the Hunter x Hunter API, and the container app, which is the name of the container app actually. Here we have the container app and the container environment too for our application. You can find it actually right here. And also we need the resource group that we are working on. Great. And I will use the build ID of each build in order to push it with a tag. So here, as you can see, I'm using the task of Docker2, which is responsible for pushing to Azure Container Registry our image. So you can see I'm looking for the Docker file in order to push my image. I'm using the service connection ACR festive tech SPN, and I'm using the public agent, which is Ubuntu latest. So all this is responsible for building and pushing the image to Azure Container Registry. Later, I'm using the Azure Container App task in order to deploy the image with its tag that we have built actually and pushed to Azure Container Registry to the dedicated container app name. And we can update also actually the ingress target port and put it internally or externally. For the demo, I will use external, so I'll change this API to being external just to see how it's being updated. So here, this is my pipeline, and here, if you can see inside the Docker task, we can check the connection type, the Azure subscription. For here, I have configured a service connection, which is festive tech connection. And we can set up also too many things from this task on the right line. So this is the pipeline. For that, we need also to configure our service connections from this menu right here. As you can see, I have one for ACR and one for deploying to Azure Container Apps. Here, if I edit this, you can see I have set up an Azure Service Manager using Service Principal. And you can actually set up a new one by clicking on Set up a new connection. new service connection and choose the type of dedicated resource manager. Okay, great. So this is how I configure this, and also the same for the Docker registry. We need to configure this from new service connection. We choose the task Docker here, and inside this task we can choose Docker registry and Azure Container Registry and choose the subscription and the Azure Container Registry dedicated or that exists inside that subscription. So here, if I change to the right subscription, I will see the Azure Container Registry of Azure Festive Tech. Okay, so let's run this pipeline in order to see how it will work. We have two jobs: build and push to Azure Container Registry, and later update the Azure Container app. I will keep this application here. So we have the tag 653 that is being deployed, that is actually deployed. And right now, if I am correct, this build will build the tag 654 and deploy to our Azure Container Apps. Okay, so Docker right now is pushing and it's done. Great, and the new job will start in a few seconds. Let's go to Azure Container Registry. As you can see here, we have the new tag being pushed at 654. Great. So the first job have succeeded. Right now we will wait for the second job that will change from 653 inside the Azure Container Apps to 654, and that means creating a new revision right here. Okay, let's refresh and wait. As you can see here, we have the new image tag being deployed. And here, if I refresh the page, we will see that our pipeline have finished it already. And like that, we have used Azure DevOps in order to deploy a new revision inside our Azure Container Apps. And it's working just fine. So this was about Azure DevOps. Let's check in the next part how to use Terraform in order to deploy these infrastructure. So let's check this together. Now the last thing, and I will be quick about it, can we deploy Azure Container Apps with Terraform? The answer is yes. All we have to do is go to the website of Terraform and we'll find out about the configuration. As you can see here, by default, I'm going to create a resource group. Like that, I'm going to define Azure Log Analytic workspace. You can, if you want, for example, to create the registry, you can create it like that and give managed identity access to that Azure Container Registry in order to pull from it to the app. And as you can see here, I can create the Azure Container App environment like that. So I need to define the name, the location, the resource group, and the log analytic workspace ID that I have configured. Also, I need to configure the Azure RM Container App, and I need to set up the registry. And if I have a template, for example, if I have already pushed some image, I can configure it just right here. And here we need to change this in order to configure the registry. So like that, we will have, for example, this is the internal app, and here we have the front-end application that we will use it to set up right here. And here we set up the template that will contain this environment variable that will refer to the backend application that we have just configured before in order to have that API-based URL. As you can see here, for the front end, we have put the target power to 80 and its external enabled to true. And for revision mode, we can change it from single to multiple. As you can see here, it's single, so it's 100% traffic to that application. If I do Terraform validate, it will perfectly run and validate this configuration. So like that, this was the last part of our demo, and I hope you like this. If you want more, you can check my website at achrafbenalaya.com. I hope you enjoyed this demo with festive tag calendar. Thank you.